This is the result. The player responds to all 8 mapped keys, stops when I release them, meets every wall, and stays contained in every corner. The movement comes from one small file, and the visible collision outlines come from the real Godot version 4.7 scene we completed in Lesson 6. One file, 8 keys, 4 walls, and 4 corners. We will build the behavior, inspect exactly what changed, test every row, and recover cleanly if the script is attached to the wrong node or an edit damages more than the one allowed file. If you follow the series, open a disposable copy of your Lesson 6 result. If you arrive from search, you need a character body D named player. Its circle collision shape, 4 static body 2D walls, and the 4 action names shown here. The previous lesson linked below builds that exact starting state. This is Godot, version 4.7 with res://scene/arena.tscn open. Bounds owns 4 named walls, actors owns player, and player owns player visual and player shape. Input map already contains move left, move right, move up, and move down, each with an arrow and 1 recorded second key. Run current scene and press left arrow. The player remains centered because Lesson 6 created intentions and collision geometry, not behavior. That stationary result is our baseline. Stop the game before changing the scene. Select player itself, not player visual. Click Attach Script above the scene dock. Choose the empty template and save the path as res://scripts/player.gd. The new file should contain only extends CharacterBody2D. Save the script and the scene. A script runs as part of the node that owns it. Player is the character body2D that has velocity and can call move and slide. Player visual only draws the icon. The script icon must appear on player. A similar looking icon 1 row lower is not close enough. Stop the game, save everything, and close Godot. In File Explorer, copy the whole disposable project folder. Rename the copy Night Bloom Chapter 3 before agent. Keep the capture cropped to this project name. No parent path or unrelated folder belongs on screen. Open the copy through Project Manager. In Project Settings, search for Name and set Application. Config Name to Night Bloom Chapter 3 before agent. Confirm that arena.tscn opens and player owns the empty script. Close this copy, then reopen the original disposable working project. You can use a local coding agent, a web chat, or no AI. The routes differ only in who types the file. Every route uses the same complete listing, the same one file boundary, and the same running tests. An AI answer is a proposal, not proof that the game works. For a local agent, first ask it to inspect without editing. It should name the one project folder and list project.godot, scenes, and scripts. Do not open a parent folder, a zip, or a collection of checkpoints. Keep approvals bounded to this project and this request. The request authorizes only scripts/player.gd. It names the 4 existing actions, input.getVector, move and slide, and an exported speed of 240.0. It forbids scene, node, action, dependency, and other file changes. The acceptance test is for direction movement, normalized diagonal input, and wall containment. For web chat, open player.gd in Godot, select all, copy the complete current file, and paste it with the same request. Ask for 1 complete replacement in 1 GD script block. The chat cannot edit the project. Compare its answer before you replace anything. For the no AI route, skip the request and type the complete file printed in this lesson. This is not a lesser route. The important skills are controlling the change, understanding the code, and proving the result yourself. After a local agent edit, ask for a read-only list of every changed file. The receipt for this request must contain exactly script/player.gd. The scene attachment happened before the request. The agent was not authorized to edit the scene or input map. If the receipt names project.godot, scene/arena.tscn, or any other path, Do not press play. Close Godot. Mark the damaged folder failed, do not use, and reopen the clean before agent copy. A broad answer is not something a beginner should repair by guessing. Before running, compare the proposal from top to bottom with this complete listing. Check the base type, typed exported speed, physics callback, action order, velocity assignment, and final movement call. No extra helper, state machine, acceleration, animation, or second file belongs here. Extends CharacterBody2D gives this script the player body's movement API. The exported variable is a typed floating point value named speed, set to 240.0. It represents screen pixels per second and will also appear in the inspector as one deliberate tuning control. Physics process runs on Godot's fixed physics step. Its delta parameter is named with a leading underscore because this short file does not use it directly. We assign velocity in pixels per second. Move and slide applies the physics time step itself. Input.getVector reads -x, +x, -y, and +y in that order. Left, right, up, then down. It returns one vector to direction. Godot limits that vector's length to 1, so combining two directions does not create a larger input magnitude than a straight direction. The next line multiplies direction by speed and stores the result in the player's velocity. A left direction produces a -x velocity. Right produces +x. Up produces -y. And down produces +y. No key pressed produces the 0 vector and therefore 0 requested velocity. Move and slide move the CharacterBody2D from its velocity during the physics step. When the player meets a collision body, Go applies the slide response instead of letting the circle pass through it. Do not multiply this velocity by delta. That would mix a per second velocity with a per frame motion value. Save player.gd. If another tool edited the file while Godot was open, return to the editor and reopen its script tab so the visible text is the saved text. Confirm the script icon is on player and the output panel shows no parser error. Only then run the scene. Run current scene. Click inside the game and hold left arrow. The player now moves left and stops at the visible wall outline. This proves more than a clean code panel. Real input reached the exact action, moved the real player, and met the real collision geometry. Reset to the center and test the required error rows one at a time. Left, right, up, and down. Release between rows. The key display names the physical key. The proof rail names the action, and the running player supplies the observation. Mark a row green only after the expected direction appears. Now test the second event recorded for each action. On common QWERTY, those are a, D, W, and S. Your displayed letters may differ. Use the actual 4 labels you recorded in input map, and reserve every arrow as the layout independent route. If one row fails, stop and expand only that action in input map. Test its arrow first. If the arrow works, repair only the second event for your keyboard layout. Do not rename the action and do not change player.gd to match a typo. Hold left arrow and up arrow together. Then compare that travel with one straight direction for roughly the same time. The live result should show no obvious speed jump. This is a visual smoke test. It is not an exact measurement of your copy by itself. The technical reason is visible in the unchanged file. Input.getVector limits the direction length to 1 before we multiply by 240.0. The authored Chapter 3 recovery reference separately passed an automated exact check. That reference result does not certify the project you are building, which is why we still run the smoke test. While the player is moving, release every key. The key display clears, the input direction becomes 0, velocity becomes 0, and the player stops. Repeat this after a diagonal input so the release test is not hidden inside a direction change. Reset and hold left until the player can move no farther. Then reset and hold right. In both cases, the circle remains inside the arena and the collision overlay stays aligned with the saved shapes. Record the observed stop, not a number predicted before capture. Repeat the same test against top wall and bottom wall. A green pass means genuine input continued while the player remained contained. A still image of the scene tree cannot replace this running evidence, and a clean script cannot replace it either. Now hold 2 directions into each corner: left plus up, right plus up, left plus down, and right plus down. The player may slide along one edge while approaching, but the circle must remain inside at all 4 corners. Mark each corner separately instead of calling one corner proof for all 4. The required receipt is now 8 key rows, 1 diagonal smoke test, 1 clear release, 4 wall stops, and 4 contained corners. If any row is missing, the lesson is not finished. Fix that row and repeat the same input that exposed the failure. If nothing moves or Go rejects the script, stop and inspect the scene doc. The script must be attached to player, not player visual. Player is the character body 2D. Player visual is only a sprite 2D. Move the attachment to the correct node, save, and repeat the original left arrow test. If movement works but the player crosses a wall, inspect geometry before code. Confirm the named wall directly owns its collision shape 2D and a non-empty rectangle resource. Confirm player owns player shape and its circle resource. Repair the missing ownership or shape, then repeat that exact wall test. For a script error, open the first error in the bottom panel. This disposable example is missing the closing parenthesis after the 4 action names. Compare that line with the complete listing. Restore the parenthesis, save, confirm the error clears, and rerun one movement test. If several lines are unrecognizable or another file changed, stop. Close Godot. Keep the damaged folder with failed. Do not use in its name, and reopen Nightbloom Chapter 3 before agent through Project Manager. That copy preserves the actions, player, walls, and empty attached script. Never merge recovery files over a project that is open. After every required test passes, you may add the 1, J, K, and L keys as extra input map events: J for left, L for right, I for up, and K for down. Test only those new keys and keep them if they help. Player.gd does not change. Stop, save, and close Godot. Copy the whole working project and rename the copy Nightbloom Chapter 3 Player Controls. Open it through Project Manager and set its application name to Nightbloom Chapter 3 Player Controls. Then open arena.tscn and run the current scene. In the reopen checkpoint, repeat the 8 key rows, diagonal smoke test, release test, 4 walls, and 4 corners. The final checkpoint passes only when the copied project opens and the same running observations still pass. The recovery reference cannot substitute for this test of your copy. You now have a complete beginner movement controller, stable input actions, one readable behavior file, equal intent diagonal input, a clear stop on release, and genuine collision response around the entire arena. You also have a rollback that makes the next bounded edit safer. Next, we will begin Chapter 4 from this checkpoint and build a reusable Wisp enemy scene. The player movement and wall tests stay intact while we add one new scene with a clear owner and a testable job. This tutorial completes Chapter 3 of Make Your First Godot Game with an AI Agent by Chris Markins. The video gives you the full standalone build and tests. The book adds the printable sequence, keyboard, layout worksheet, recovery checkpoint and hash, and the surrounding project context. The book and free series companion are linked below. Continue through the Godot version 4.7 beginner series here.